So good afternoon, everybody. Welcome to this afternoon session on of virtual dev days, to this introduction to Firepath. My name is Gustav Weller, and I'll be your host today. Our speaker is Mirjam Baltus. Mirjam is a fire trainer and a friendly, competent support engineer at FHIRPath. You might know her through fire training courses and workshops. And without further ado, I think I'll just pass on to Mirjam. Welcome.
Thank you, Gustav. And welcome to all of you to this introduction to Firepath presentation that I have for you today. Well, Gustav already introduced me. This is me. I've been part of the Fire team since almost the beginning. If you watched Ewout's opening video on the first day, you know that Fire by now is about 10 years old. So yeah, 2012. That's also almost 10 years ago, right? So I work for FHIRPath, and FHIRPath is of course known for DevDays, organizing DevDays, but we also do all kinds of other stuff. So I am the fire trainer, and we have teams working on tooling, and Gustav is one of our partners at Helix. So that's also really nice to have him here as my backup support. So Firepath, we're going to take a look at that. It's a path-based navigation and extracting language. So the idea is that you use Firepath in order to navigate through a structure and then extract something from that structure. You could compare it to XPath. Well, in my view, Firepath is a little bit more readable, but that's up to you to decide what you like best. Firepath you will encounter during your fire work because the fire specification uses Firepath quite heavily at some points. Firepath is a graph traversal language. You will have to have a graph that you can walk through, and your data has to be represented as a tree, and then you can use Firepath in order to work with that. It has a syntax based on fluent interface patterns. So if you're familiar with that, you might encounter things that you already know about, and that makes it hopefully a little bit easier to work with as well. It doesn't matter which platform or model you work with because Firepath can be used on any platform you want. We will also, by the way, see that Firepath deals with collections of the values. Firepath is called Firepath because it was a standard that was evolved next to Fire and mainly done in order to be able to work in certain parts in the Fire specification, but it's not limited to use for Fire. So you can use it for other structures as well. As long as you can represent them as a tree structure, your data can work with Fire. So it is independent of the model that you use. Now, of course, if we do look at the fire specification, you will see that Firepath can be used to navigate to point to certain parts of a resource instance. And this is done, for example, for the search parameter definitions. And also, if you have the fire patch interaction that you want to do, you can create a Firepath expression in your fire patch object and then patch the data on a fire server. Also, we will see that you can have formal constraints, or sometimes also called invariants, for structure definitions. You will see them in the Fire specification already, but you can also use Firepath for your own profiles in order to formulate such predicates, so extra constraints. And next to that, you can also use it to extract data from an instance. So for example, if you have a structure coming in that does not have a narrative part attached to it, you could use Firepath to point to certain parts of that instance, extract data, and then use that in combination with a template you have lying around for the narrative. Fill the narrative with those extra data points that you get from the actual structure. And then you can use that for narrative generation. Here's an example of search parameters that you can encounter. And then if you look at those search parameters, you see that there's an expression attached to those. That expression is actually a FHIRPath expression. Well, we will come to that again in a bit, but this is just already an example taken from the official FHIR specification. The other example that I mentioned was those invariants or formal constraints, and you can also find expressions there. Again, those are FHIRPath expressions. So let's take a look at what FHIRPath can offer you. So first of all, we can use it to navigate data. So for example, I have a resource here. This is a patient resource, as you can see. We have filled out some details, not too many, but you can see we have 2 names actually in the name array here. And we have an active field filled in with an extension as well. So active has both the true value and then we have an extension added to that. Again, some details have been left out just for brevity on the slide. But you can represent this data as a tree. So let us look at the tree structure. You can see we have, of course, a starting point, our root point, which would be the patient resource or the beginning of the resource. So you can see that all the way on top here. And then all of the top level elements, you can see them listed here. So the names both, and then the active. And then for those that we know the data of, you can see that we have the sub points there, the sub nodes. Each of those nodes, except for the root node, will have a name for that node, and it also will have type information if you have a typed structure in your FHIRPath implementation. So you can see the types listed for the root. Of course, the resource type is patient, and then names, well, they are of the FHIR data type human name, active is of the FHIR data type Boolean, etc. And you can see that it has an extension as well. Whenever we have filled in data, you will see that we actually have that value listed on those nodes as well. So this is the representation of my FHIR patient there. But remember, you can take any kind of structure you have. And now I have a FHIR patient represented as JSON. Of course, your FHIR patient could also come in as XML. That's no problem at all. When we have that structure, we can then use those names of the nodes to navigate through that tree. So I can create a path using those labels of the nodes and then concatenate them with a dot in between. And you can see here an example where I can navigate to name.given, and that will give me the selection of nodes that are actually the given parts here. So we have these 2 here, 2 givens for this particular name. If this second name also had given nodes added to it, well, we have left them out of the example, but then they would end up as the result of this particular path as well. The second example says patient.name.given, but you're not mandated to use that patient type there. Normally, if you are somewhere within your structure and you use a FHIRPath expression, the context will be the node that you're on at that moment, and then the FHIRPath implementation will walk from that node to down in the tree according to the path that you have given it. So both of these expressions that I have right now, they result in the same thing because in this case, we just start out with the root anyway. So that was our context. And this will end up in a collection of nodes, and those nodes take the values there, Wouter and Gert, which are actually Ewout's official names. We can also navigate in other ways. So for example, we can select the children of a certain node. So in this case, patient, we are still on the top level there. Patient.children will give me all of the direct children of that node. So you can see the nodes that I get in my collection highlighted in red. If you use descendants, you will get all of the descendants that are for that node that we are starting with. So again, we're starting at the root, and that means that we get all of those in our collection. Now that name node here is of type human name, that will have the other parts in there as well. So selecting this one in my collection will have all of the information from its children as well, because it's the human name data type. But we will also have the family and the given, etc., in our actual resulting collection from this particular FHIRPath expression. So that's navigating through the tree. Oh, I'm sorry. We can also do some other things. For example, we could have all of the descendants and then say, I want all of the descendants and then actually those that have a use node, and that will result in this actual node here. So the FHIRPath implementation or tooling will then walk through all of the nodes, check whether they are called use, and select those. So even if we have a use node somewhere else in the tree, that will also be added to our collection as well. Now, I've mentioned those collections in FHIRPath. Everything results in a collection. It can also be an empty collection, by the way, if you have no results on your FHIRPath expression. But then if you have that collection, you can do things. For example, you see here that we can do a count. So we could do a patient.name.count, and then that will give us the amount of names in the patient here. So in our example, that would be 2, because you know there are 2 names in my patient array there, patient name array. But we could also select, for example, the first one of that collection or the last one. So you see a couple of examples there as well. Now you can even use the first function here on a node that actually just is a singular node. So patient.active is a field that can only occur once in the patient. And then we could select the first, but that will be the same as when we just set patient.active. So, well, in that case, it doesn't really make sense to do a first on that. But all of the functions, again, will return a collection as well. So that's something that you need to be aware of, because if you do some checking to see true and false values, the empty collection will also play a role in the outcome of your checks. We've just seen that we can select all of the use nodes from our descendants, but we can also take into account the values of the nodes instead of only just the labels. And that's done here with the where function. So that's actually a selection, select statement that we have. So I can do patient.name. So look to all of the names in the patient, and then check if there is a use field that is set to official. So the value of the use field has to be official in order for this, of course, to be true. And then that will end up in our collection. So this will walk through all of the names that are in the patient, check that use field. And if that is the thing that matches, then the name block will be in my collection. So actually that use field is there, and then we would have the name ending up in the selection, because the use node that is part of that name contains that actual value that we check for. Now you have all kinds of other functions, and a couple of very interesting ones or useful ones are testing for existence. We can check to see whether something is empty or something exists. So you see some examples here. Well, empty, of course, is checking whether there is something in a collection. If the collection is empty, you get a true. If it's not empty, you get a false. But you can also test for existence and then also check for criteria. So the first example here is identifier.exists. That will just check whether there is an identifier present in my patient in this case. But we can also give some extra criteria to that, and that's the second statement, where we check whether there's an identifier that exists with the use node having the value of official. So that's an extra select on that exists. And of course, you can also do things with Boolean operators, where you can see an example here. We want to check whether the telecom field exists, where the system is set to phone and the use is set to mobile. So that means that this would result in a telecom object that is about a mobile phone. So you can then use that value, or perhaps put that value in a specific database table field that you have for mobile phones. Now, I've just mentioned those Boolean operators. You have, of course, the AND and the OR, but also the XOR and the implies. I do like the implies, because then you can do a statement. If that is true, then that results in the second statement after the implies keyword to also need to be true. So if this is true, then that will also have to be true in order for the implies function to result in a true value overall. Next to Boolean operators, you can also do comparisons. So for example, if we have a number or something like that, or a date, we can compare them with the normal comparators that you know about: greater than, less than, etc., and not equal. So that's all there. If we look at the Firepath specification, and I will show you an example in a bit on the website, you can also find all kinds of string manipulation functions. One that you see often used is, for example, the matches, where you fill in a regular expression, and then you can check whether a specific string value matches that regular expression. And then according to what the outcome is, you can do something with that, either reject some data if it doesn't match a required expression that you have, or do some other checks. What's not on this slide is that you can also manipulate strings by setting everything to uppercase or lowercase, which could be really useful if you need to do searches. And those searches do not need to be case sensitive. Then you can convert all of the strings that you take out from your data, manipulate them to be all lowercase, and then store that as your index values. So all those kind of functions can help you out with working with your data, and Firepath gets to be quite powerful if you use those things. Well, you can also do calculations, as you can see, so the normal operators for dividing, adding, etc. That's all in the Firepath specification as well. Now let's take a look at some actual examples here. So if you did my intro to profiling session, I have mentioned Firepath as being something that you can use for creating formal constraints. So I want to just run through a simple example here, and also show you what you can find in the Fire specification, of course. If you're profiling, then you usually start with changing cardinalities and doing things with data types and things like that. But sometimes you have extra requirements, extra conditions that you want to formulate. So I have two here: a patient's birth date must be on or before today's date. That could be a check that you really want to do on the level of a profile when you check your data against that profile. And that's something that you cannot express through cardinalities, etc. You have to do some kind of other check, and that's where Firepath comes in. I have another one that we will work through in the next couple of slides as well. As you can see, that can be just an expression that works on a single element, like that patient's birth date. The second one actually covers multiple elements in the data, and then you can do a check over those as well. For those formal constraints, it is important that the Firepath expression evaluates to either true or false, because a validator will take that Firepath expression and then needs to decide whether this data is valid or not. So that has to be a true or a false that comes out of there. When we look at those constraints, then constraints have to be declared on the lowest element in the hierarchy. So that is still common to everything that you use. Of course, if you use a single node, a single element, then that constraint can just go on that single element. But if multiple elements are involved, you are going to have to find the common parent of those and then put the constraint on that level. Then every constraint gets its own key. That has to be a unique key for that particular structure. Then the validator can use that in order to inform anyone if that particular rule has not been satisfied. I have an example here from the FHIR specification where this is a screenshot of the observation resource type. And if you look at the constraints for the observation resource type, you can see that there are 3 of those extra constraints, those formal constraints mentioned. And the keys there, they are OBS-3, -6, and -7. There were more, but during the evolving of the FHIR specification, some of the other rules have fallen out and have been removed. But the FHIR specification always uses 3 letters, a dash, and then digits in order to indicate that particular rule on resource type. The 3 letters are usually the first 3 or a kind of a shortage of shortening, I should say, of the resource type name. So OBS for observation, BDL for bundle, things like that. So by looking at the key, well, if you have a little bit more experience with that, you could already identify what actual structure this comes from, what you are violating, what kind of rule. For each formal constraint, you will also define the severity, and that could be either an error or a warning. In the FHIR specification, if you see that level saying rule, then that means it's an error when you do not satisfy that expression that's mentioned there. If it's a warning, it will say a level of warning. Then that means that a validator will give you a warning when the rule is not satisfied, but it's not a hard error, so your data will not be rejected on that. So let us look at that second one that I had. If a cholesterol value result is not available, I'm talking about observations for cholesterol values, then use the note field. Well, that means that if you use both, that's okay. We just want to have at least one of those 2 filled in. So they cannot both be empty. And that means that we can do a check with the exists function in order to see whether one of those exists. And if we translate that to a FHIRPath expression, you can say, okay, we take a look at the value quantity field and check whether that exists. So value quantity exists, or note exists. Since this is an or, it's still okay if both exist, but at least one of those have to exist in order for this particular expression to evaluate to true. So we can put this on our profile in order to make sure that this is a rule that is taken into account by the validator. Here you can see another screenshot of some parts of the observation, and you can see observation can take the value of type quantity, and further down you can see there's a note field. So those are the 2 fields that are involved here. So value quantity there and note. And that's where I want to have this particular constraint work for. Now, as I said, if you have multiple fields involved, then what you need to do is find the common parent of those fields. In this case, that's just the observation type, so the top level of observation here, because that is the common parent of both of those 2 fields, the value quantity and the note. So our formal constraint has to be formulated on the common parent. So my constraint works on the elements of the value quantity and note, but we put it on that top level, since that is our common parent, and we call that the context. Then we give it a key, that unique value. You can use a similar mechanism as the FHIR specification with 3 letters and a digit, but you can use anything else as well, as long as it's a unique string within the observations constraints that you have. both the already existing ones from the specification as well as other constraints that you might put in your profile. And of course, we need to think about whether this is an error or a warning. And actually what we also need to do, and I forgot to put that on this slide, but we also need to create an error message in order for the validator to be able to use that message whenever this particular rule is not satisfied. And then it will just end up in, for example, the operation outcome that comes out of the validation operation. Now, what we also will do is on the value field and on the node field, we will refer to that actual constraint that we've created on the observation level, because that will be the indication for a renderer to put in a kind of a flag or an icon indicating that these two fields are involved in that invariant, in that constraint. So that's a nice to have. It doesn't do anything for validation actually, but it's really nice if you as a profile author would do that. So the renderer can automatically render that correctly for any user that looks at your profile. So that's not what I wanted to show. There are tools, but we will come back to that. I will come back to that slide. I put them in the wrong order there. The last one that I still wanted to talk to you about was the search parameters. So you can see a screenshot here of the selection of the search parameters of the patient resource. And those expressions on the right-hand side, they are the expressions, the Firepath expressions that are already in those search parameters. So that's what you see in the core spec. The work group that's responsible for that particular resource type, they decide on the list of search parameters that are the default or the standard search parameters. And actually not all of the fields within a Fire resource type are searchable by default, because the work group selects just the set that they think, through all kinds of discussions, of course, and input from the Fire community, that they think is a good list of search parameters. That Firepath expression points to the value, so usually that's a path. So for example, we could have patient.name.family, which will select the family name and the patient's name and the patient's human name. But you can also see that functions are used, so those extra selections, those extra criteria can be set on that as well. So in this case, what we have here is a patient.telecom. And again, this is just taken from the Fire specification, so you can find quite a lot of examples in there. We want to take a look at patient.telecom, where the system equals email. And then the value that is part of that telecom block would be the actual email value. And then you can use that for a search on the email search parameter. So that's something that you could encounter in the base specification. And if you develop a Fire system, a Fire server, then you can use that expression to get that bit of information in order to get to the actual values you want to put in your search index. But because not all fields are searchable by default, you might have the need to create your own custom search parameter. Often that's done to support searching on extension values, because for extensions, the Fire specification does not have standard search parameters. So if you need to support searching on extension values, you will also need to create a search parameter definition for those. But also, those fields that you miss out on because the work group has not decided that that's one of the standard searchable fields, those fields you can still support search on by creating your own search parameter and then pointing to that exact path. Now, I have an example here taken from the US Core Implementation Guide. They have defined US Core race extension, but also they have defined a search parameter for that US Core race search if you need to do that. And in the implementation guide, actually, we created a list of search parameters that systems that want to support the US Core Implementation Guide, they would have to implement support for that particular search parameter as as well, but they have given you the search parameters, so you do not have to create them yourselves. So here's an example. I've taken out most of the parts of the search parameter, but the expression, of course, is the FHIRPath expression again. So we see that they say, okay, this search parameter looks at patient.extension. And then we have a where clause selecting just those extensions with the URL listed here. So that's the US core race canonical URL in that where clause. So only extensions with the US core race URL, they are selected. And then because it's a complex extension, they even go a level deeper. So they look at the extensions within this main extension to check the value of the code that's in there. And then that will result in those values, the code values that might be in those extensions. And you can use those, of course, in your index tables again, in order to support searching on US core race. Of course, creating a search parameter, there's all kinds of other things that you need to take into account, but that goes beyond what I want to talk to you about for Firepath. So that's not on the slide, but if you need to create search parameters, do take a look at the other parts involved here as well. But fortunately for US Core, at least, they have already given you these extra search parameters, so you can just copy them or use them, ingest them into your own systems. And you're good to go for supporting that particular search parameter. Now let's go back to that slide that I've just skipped over. That's a slide with just some links here. Actually, 2 links, well, 3 links, but 2 tools. One is an online Firepath demo, which I will use in a bit to show you some Firepath expressions. And then you also have a Firepath tester implementation. It's available as a Microsoft tool, as you can see, but it's also a project on GitHub open source, so you can download that. It's from Brian Postlethwaite, and he is a valued member of the Fire community. He contributes quite a lot to the Firely SDK for Fire, the .NET SDK. And he has created that Firepath tester tool as a demo of what you can do with Firepath, but you can test your Firepath expressions with that. Since it's a Windows-based tool and I'm on a MacBook, I do not want to start up my my virtual machine here because it takes up too much memory and well, the connection might drop off then. I will not show that one, but it's a really valuable tool as well. By the way, it also contains code that can work with all kinds of Fire versions, so the STU2, STU3, R4, etc. So it's a good example if you want to work with a project with multiple Fire versions, well, to see what he has done to incorporate all of those in that particular tool. So I'm going to use that online Firepath demo, and I will also show you that use of an extension. We still have some minutes for that, so that's good. So let me end this show. So first of all, I would like to show you that that search parameter and what you can do with that if you have a system that can dynamically ingest search parameters. So I have prepared an example here. I'm in my Postman, and you can see I've prepared a query searching patients for a birthplace with a value, and I limit the count to 1 just to make sure that I don't get a large bundle back. And I run this on my local Firely server, but you could try this on the public Firely server as well, or download your own copy of the binaries and you can try this out yourselves. So what I'm doing is just a search. So let me just see what this results in. My server is running on the background. So you can see I get a 200 OK, and I get a bundle back. And I even get a patient in there. So we could now check that patient to see whether he has a birthplace and whether that matches my query. Well, you can see clearly this is not AMS, which stands for Amsterdam. It's a different birthplace. This patient does have a birthplace, but it's not my birthplace search. So check further down and you will see that there's also an operation outcome in my bundle here. And if I check the details, this will say that I do not have the parameter birthplace implemented. It's not a standard search parameter. It's a search on an extension. So I would have to make sure that the server knows how to search for birthplaces. And I haven't done that yet, of course, because of this demo. But this is just an example of what you could encounter, a server that does not have that search parameter supported. So what I can do now is take my actual search parameter and I can let my server know about that. So I've prepared that. In this case, it's XML, doesn't really matter. But you can see the expression here. That's the important for this particular presentation. I'm looking at this particular structure definition, patient birthplace. That's the extension's canonical URL. And I want to index on the value of that. So that hopefully does the trick. So I post this to the administration part of my server. And it says 201 created, so yay. Let's do the search again. And now I get a better result, as you can see. Well, even though the total number of results is 0, you do see that the patient's birthplace is in my self-link. So it is now supported. I do not see that operation outcome anymore. The server now knows about that search parameter. Existing data needs to be re-indexed in order for this actual birthplace to result in anything. Or if you send in new data, then you will also be able to have the server automatically index on that. So let me just quickly go to my database here to show you. This is that patient that I have prepared, patient Mirjam, so that's me. Here are some index tables for that. And if you look through them, you will not see the birthplace. So we have a family given, etc., etc. But the birthplace is not in here. Even though if you would look at the patient, you will see that there's a patient birthplace extension on there. This was already existing data, so my server has not indexed it yet because I've just uploaded the search parameter. Now, if I would do an update on that particular patient, then that will have the server index on the field. I could also do a re-indexing, which is possible there, but I don't want to have the server run too long on that. It probably would not, but let me just quickly put this. So this is now newly created, and you can do a search again. Let me see if this results in anything now. And yay, we have patient Mirjam here, which would be the result of this particular search for Amsterdam. So there's a total of 1. So that is working now. You can see that new data or data that's being updated on my system now gets indexed for that search parameter that's called birthplace. And if, of course, I would look at this one, just refresh that one. Well, I should see the current one. Yeah, that's this one. I can look at the string index here. Now there's 7 elements. For those of you who have just seen, there were 6. And this last one now, that does say that's birthplace. So that's the index on birthplace now being present for this particular patient. Of course, if I would do the re-index on all the patients in my server, then all the patients that have a birthplace extension will now be able to be searched for that particular value as well. So that was a quick demo on that. Yeah, it worked. So yay for yay for demos, live demos, always nice. Did you have a question there, Gustav?
Yeah, that was great. It was a great presentation. So I do have some questions, but I'll give precedence to hear a few other questions. So we have a question by Janice on children versus descendants. So the question is, if you use children, you just get 1 level down, but descendants give you the entire tree below the current spot, question mark. Yeah.
So I am running now the FHIRPath demo tool, the FHIRPath.js, which the link is in the presentation, and I can also put it in the comments later on if you want. By default, it comes with a patient in there already in YAML form, but you can also convert that or change that to JSON if you like that better. But if I do patient.children, you will see that I get these Let me just take out a little bit of this, and then you will be able to just see a couple of the fields at the side there. Well, there's quite a lot. They have given me an extensive example there of all kinds of things that could be in the patient. I think it's the example patient actually that's in there. So hopefully I didn't mess up my JSON now. But you can see that we have patient, then we have the ID field, that's the example here. And then we have that dash that gives us that block of a name. And we have a dash that gives us the second name and the third name here. The birth date, the active, and then we have, the deceased and the active. So that's all in there. But now if I would do descendants, then that will indeed give me all of the fields as well in the results. So try to fill it in correctly while talking. And you can see that actually we start off with the same top level blocks here with the names, etc., etc. But as soon as we've reached that last one, the active equaling true, now the Firepath evaluator moves a level down, and you can see official is now the value of a node as well. So that's on this level, the use node here, that gives me the value official. And then we have the given, which gives me those two strings here, or there's two given actually. So that would be Peter and James. So you can see that all of those nodes now, all of the descendants of the top level, they are now in my result list, in my collection. So does that answer that question, you think, Gustav?
I think it fully answers it. So we have another question which was upvoted. Actually, I was going to ask something on those lines. It's slightly imprecise, but you'll probably correct that. So what is the benefit of using Firepath over CQL for extracting data?
I wouldn't actually know the answer to that. I don't know if you have an answer to that, Gustav, but I do know that Firepath is used throughout the Fire specification, and that's why it's important to at least know what Firepath is and see some examples there. But it might not be the end all of things, or the thing that you need to use for all extracting of data or other use cases as well. So I don't know, Gustav, if you have any addition to that, but.
I think I'd rather go for the compatibility. So it will probably scale better on different applications, because usually CQL is not supported. So I think that's the reason I'd go for Firepath. But that's the only answer actually I do have.
Yeah. Of course, if you talk to someone who's an expert on CQL, which I am not, I have to admit, then they might have quite different ideas. So please do also ask them what they think about CQL versus Firepath. I would not mind if they gave a different answer. That's perfectly okay.
Yeah, I think most implementations are either incomplete, so that would be something which would worry me. So that would be the main reason.
And there is Firepath support in the main libraries. So if you look at the .NET SDK or the Happy libraries, they have all integrated Firepath support in that. So you can just use it out of the box there.
Okay, so we've got another question which was upvoted. Should custom search parameter Firepath expressions that target extensions always include .value at the end?
Yes, they should. There was a reason for that, but it eludes me. I do know that in the Fire specification, sometimes you do see examples where the .value is not added, but we actually want that value block. That's the node that we want to get out, because it could be just a string if it's a value string, but it could also be a complex data type, and then you get that group of information. And you would not want to have a level up. You already select on the URL, and then you actually are interested for those custom search parameters in the value that's attached to that whole thing. So it's in my view just a matter of being a level down, that value level that actually holds the interest, the interesting things, because that URL, okay, that's just a check that we want to do, but then that value, that's what we want to index on.
Yeah.
Of course, you could have implementations working differently, but I know that most implementations want you to do the doc value at the end.
Yeah. So we've got another question. Can FHIRPath navigate resource references?
And in what sense would that be navigating?
I think that's not really clear here.
This is, by the way, the FHIRPath specification here. So it's just hl7.org/FHIRPath. It is under the HL7 umbrella, so officially maintained, and with balloting rounds it will evolve, etc. So it evolves apart from the FHIR specification. So this is a different specification. But actually, if you look at this particular page, it's quite a large page, and it holds all of those functions that I mentioned. I've just shown a couple in my slides, but there are quite a lot more. And one of the things that you could see there is resolve. I probably didn't type it in correctly. No. Gustav was in the way for my screen there. So let me see. So what we have is a resolve function that you could take a look at when you want to do something with references. This, if the implementation actually supports that, would resolve a reference, and then, for example, in this case, check whether the type of the resolved URL now is of type practitioner, and then you can do something with that. So in that case, FHIRPath can do something with references and checking some things there. Yeah, it's just something that's not it's not implemented in all of the libraries yet. It's something that's coming, so a little bit more complicated than normal checking.
Yeah, so I think we are actually over time. So I've been asked to actually stop the session. I think you probably will answer. There are two other questions there.
I will check the Q&A also after this session during the rest of DevDays. So please reach out to me if you have more questions, or put another question in the Q&A, and I will happily try and answer that. Do try out this tool. It comes with that example patient, and you can just try out some different expressions that you can find also the functions for on this FHIRPath specification side. So thank you for your attendance, and well, hope to see you later.
Great, Mirjam. Thanks.
Thank you, Gustav, as well.
Also for the demo tool, that's really helpful getting started with the topic. So I wish you all happy remaining Dev Days, and you could rate this presentation, and any questions I know Mirjam will follow up on. So have a nice remaining evening, morning, afternoon, whatever it is in your part of the world. Bye-bye.
Bye.
Bye.